Hello, dear Hyundai family members. This video will introduce the brake system installed in medium or heavy-duty buses and trucks of Hyundai Motor Company. Compared to the hydraulic system used in passenger vehicles, the Hyundai brake system used in medium or heavy-duty buses and trucks has a complicated structure and many components. This video aims to help understand operations and functions of components through detailed explanation. This video contains air over hydraulic brake system and full air brake system applied in the medium or heavy-duty buses and trucks. Let's begin with the system structure of the air over hydraulic brake. The air over hydraulic brake system consists of an air compressor, air dryer, air tank, dual brake valve, quick release valve, parking brake valve, four-way protection valve, air master, and wheel cylinder. The air over hydraulic brake system is an hydraulic dual operating system. By operating the brake pedal, air pressure is controlled. The air master converts air pressure controlled in the brake pedal and operates the wheel cylinder with hydraulic pressure. Now, let's take a look at the circuit of the air over hydraulic brake system. An air compressor installed in the engine generates compressed air. Compressed air is filtered by the air dryer and stored in the air tank as clean and dry. When the driver presses the brake pedal, the dual brake valve is activated. As the circuit opens by the dual brake valve line, compressed air in the relay valve transferred from the air tank is supplied to the air master. When the air master operates by the compressed air, hydraulic pressure generates to be supplied to the wheel cylinder. The following are operations of each component used in the air over hydraulic brake system. The first is the dual brake valve. A dual brake valve is installed together with the floor brake pedal on the driver's side. In the dual brake valve, brake force controlling the valve by pressing the pedal consists of two circuits, primary and secondary, and each circuit is operated individually. In general, the primary and secondary circuits are linked to the rear wheels and the front wheels, respectively. It is the engineering deliberation to obtain the braking force even when one of the circuits fails. The dual brake valve consists of a supply port, delivery port, and exhaust port. The supply port and delivery port are connected to the air tank and relay valve, respectively. And the exhaust valve is open to the air. This time, I would like to explain the case when the driver presses the brake pedal. The primary circuit operates as follows when the driver presses the brake pedal. When the brake is pressed, force applied in the plunger pushes the primary piston, and the primary piston touches the inlet valve seat. Then, the exhaust port is closed, and the inlet valve is opened. So air from the tank is delivered to the relay valve in the rear wheels. When air is transferred to the primary circuit, air pressure is applied to the upper part of the piston through the pilot hole in the upper body. The relay piston closes the exhaust port and opens the inlet valve by touching the exhaust valve seat in the secondary circuit. Then, air is supplied to the relay valve in the front wheel from the air tank. Now let's deal with the case when the pedal is released. When the driver releases the brake pedal, mechanical force to the pedal disappears in the primary circuit, and then air pressure in the valve and spring force open the exhaust valve with the primary piston. Then, air flowing to the exit is discharged through the exhaust piston. Likewise, with the primary circuit, the relay piston opens the exhaust valve in the secondary circuit. Then, air flowing to the exit is discharged through the exhaust port. The following is an explanation for the case when the primary circuit line is leaking or damaged. If the pedal is pressed when the supply pressure of the primary circuit has no pressure for any reason, the primary piston delivers mechanical force to the relay piston to open the inlet valve. If the pedal is pressed under the supply pressure disconnection of the secondary circuit when the secondary circuit line is leaking or damaged, the primary circuit operates only as explained above. Now let's go to the relay valve. Air from the air tank stays in the relay valve all the time. When the driver applies the brake pedal, air supplied from the brake valve transmits the signal to the relay valve. Then, air in the relay valve flows to the air master to operate. A relay valve is installed to perform accurate braking without time lag to meet the driver's intention. Air supplied from the air tank by the relay valve pushes the piston plate in the air master chamber. When the power piston pushes the hydraulic piston, hydraulic pressure generates at the hydraulic piston connected to the oil reservoir tank. Hydraulic pressure expands the wheel cylinder installed in the drum. Then the lining expands inside the drum and braking force generates by the friction between lining and drum. Two air masters are installed. As shown in the figure of the 6x4 vehicle, a slightly bigger air master controls the first and third axle. A smaller air master controls the second axle only because the second axle requires the largest braking force. Let's take a look at the stroke switch this time. If oil leaks in the hydraulic line, or pressure drops due to certain problems, or the lining is worn out, the push rod stroke increases. Since this influences brake performance seriously, the warning lamp warns the driver. The stroke switch operates the warning lamp. If oil leaks or the lining is worn out excessively, the stroke increases as shown in the figure from the normal stroke. Then, the piston plate touches the stroke switch and the warning lamp turns on. The engine operates the air compressor. While the engine is running, compressed air is generated continuously by the up and down movement of the piston. Engine oil is used for piston lubrication. Timing should be set when the air compressor is installed in case of mechanical engine. Let's take a look at the air dryer. Since the AOH type, or full air type, uses compressed air, the air dryer performs very important functions. Compressed air by the air compressor generates the high temperature. Moisture generates in the compressed air passing through the air line. Since this moisture causes corrosion, moisture should be eliminated. The air dryer eliminates this moisture. Compressed air generated in the air compressor passes through the annular filter, the first filter by way of the air dryer exit. Then, engine oil and impurities are filtered. Moisture is eliminated as the air passes through the desiccant. The filtered air is charged to the maximum pressure of the air tank by way of a check valve. If the engine is running or the brake or other accessory equipment are not used, the internal pressure of the system reaches to the maximum pressure set in advance. This pressure is thus called cutout pressure. When the pressure of the compressed air reaches to the cutout pressure, the governor piston, supported by the double spring, moves to the right and the passage opens. Compressed air is transferred to the purge piston to move the purge piston downward. When the passage opens that was shut by the purge piston, air generated from the air compressor is discharged. Then air charged in the purge tank moves backwards and cleans the filter and removes the impurities stuck in the desiccant. When the brake or other accessory equipment are used, air charged in the air tank is consumed and air pressure reduces to the minimum pressure set in advance. This pressure is thus called cut-in pressure. If the system pressure drops down to the cut-in pressure, the governor piston is closed. Then, pressure applied to the upper purge piston reduces and the air passage gets closed. Therefore, compressed air is charged. Cutout pressure and cut-in pressure can be set. Though they are set in advance when they are manufactured at the factory, they should not be set as their own way. If set, it may result in the functional deterioration or serious part damage. Now let's turn to the air dryer checkup. The filter cartridge at the upper air dryer should be replaced periodically. Replacement interval is 1 year or 50,000 kilometers, whichever comes first. However, the replacement interval may be shortened under severe conditions, so frequent checkups are required in that case. To check the air dryer, open the drain cock valve manually, installed at the bottom side of the air tank to see if it drains moisture or engine oil excessively. If the drain is excessive, replace the filter cartridge. A heater is installed in the air dryer to prevent freezing in winter, which operates automatically depending on the ambient temperature. It turns on 7 plus or minus 6 degrees centigrade and turns off at 29 plus or minus 3.5 degrees centigrade automatically. To check the heater, touch the air dryer body by your hand when the ambient temperature is low. If it's warm, it's normal. Otherwise, replace the air dryer. If the supply port of the air dryer contains much engine oil, the filter cartridge desiccant is polluted and desiccating function is lowered conspicuously. Then, the filter cartridge should be replaced. If engine oil keeps draining even after the replacement, check the air compressor because it means oil links from the air compressor to the air dryer. Engine oil, lubricant, flows into the air line due to some specific internal problem of the air compressor. The four-way protection valve shuts the airflow until the air pressure reaches to the preset level. This is the safety functioning equipment of the brake system, which assures the braking force even when air pressure drops due to some reasons such as excessive use of accessory equipment or others. This equipment, installed between the main air tank and the accessory tank, opens the air passage so that the air flows to the accessory air tank through the delivery port when the main air tank pressure reaches the preset level. We've learned about the AOH system so far. Now, let's learn about the full air brake system. This system operates as follows. The full air brake system uses compressed air only. Most components are shared with the air-over-hydraulic brake system. Through an R12 relay valve, R14 double check valve and relay valve, spring brake chamber, and slack adjuster are unique components of the full air brake system. Now, let me explain the layout of the full air brake system. Compressed air is generated in the air compressor installed in the engine. Compressed air is filtered by the air dryer and stored in the air tank as clean and dry. The dual brake valve operates when the driver presses the brake pedal to stop the vehicle. Then, the compressed air is transferred to the R12 relay valve, which is staying in the dual brake. The supplied compressed air opens the air passage of the relay valve. When the air passage inside the R12 relay valve is opened, compressed air inside the R12 relay valve is transferred to the brake chamber. If the chamber is filled with air and the pressure pushes the rod to rotate the S-cam shaft, accordingly, the brake shoe expands and brake force generates through friction with the drum. I'd like to explain the valves used in the full air brake system one by one. The first one is the relay valve. The relay valve mainly controls the air to the rear wheel brake chamber in the full air brake. The relay valve consists of a supply port, delivery port, service port, and exhaust port. Each port is connected to the air tank, brake chamber, dual brake valve, and atmosphere. When the driver presses the brake pedal, air goes to the service port connected to the dual brake valve. When air pressure is applied to the upper part of the relay piston moves downward and the exhaust port closes and the inlet valve opens to be connected to the tank. So the air pressure flows to the delivery port instantly. When the driver releases the brake pedal, signal pressure supplied to the service port is removed and force applied to the upper part of the relay piston disappears. When the force applied to the upper part of the relay piston is removed, the relay piston rises rapidly by the force applied to the lower part of the relay piston, and the inlet valve closes and the exhaust port opens. And then, air flowing to the brake chamber through the delivery port releases through the exhaust port. The quick release valve is installed between the dual brake valve and the front brake chamber. The quick release valve consists of a supply port and delivery port. The supply port is connected to the delivery port of the dual brake valve, and delivery port is connected to the front brake chamber. When the driver presses the brake pedal, air is supplied to the supply port from the dual brake valve. Then, the diaphragm moves downward to shut the exhaust seat, and air is supplied to the brake chamber through the delivery port. When the brake pedal is released, air flowing to the exit of the dual brake valve is discharged to the exhaust port of the dual brake valve, and the air pressure applied to the supply port of the quick release valve disappears. Then, pressure applied to the upper diaphragm disappears, and air pressure is applied backward to move the diaphragm upward, which used to flow to the exit. The air is discharged through the exhaust port, which has been supplied to the brake chamber. The brake chamber in the air brake system receives compressed air finally and pushes the connected slack adjuster. Then, the slack adjuster turns the cam to expand the shoe. Then, braking force is obtained. To release the braking force, discharge the compressed air in the brake chamber into the air. Then, force pushing the push rod disappears, and it returns by the force of the return spring. When the driver presses the button, the valve opens and the air that flowed from the supply port is supplied to the spring chamber through the delivery port. Therefore, parking is released by compressing the power spring. While operating, the power spring expands by the discharging air and the parking brake is engaged. When the air pressure is weaker than the spring force built in the valve due to a system failure, parking is engaged automatically without any driver operation. Spring chambers are mainly installed on the driving wheels. Besides, they're installed with the brake chamber to allow engaging or release of the parking brake by driver operation. The double check valve functions to determine airflow by selecting the higher pressure between the two supply lines. In the case when the brake pedal is depressed while the parking is applied, the pressure in the spring chamber is removed and the power spring is expanded while parking is applied. In other words, the other side port of the double check valve connected to the parking brake line is free from pressure. If the brake pedal is pressed, the pressure from the relay valve is transferred to the other port of the double check valve. Therefore, the piston in the double check valve is pressed and shuts the port in the parking line. Air pressure from the relay valve is supplied to the spring chamber to release the parking and is also applied to the brake chamber simultaneously. Therefore, the load by the double operation is prevented to protect the system. A gap between the brake lining and drum grows as they're used. Therefore, a relevant gap should be maintained through periodic adjustment, and the lining gap is adjusted by the slack adjuster in the full air brake system. Unless properly adjusted periodically, the lining gap grows excessively. Then, braking performance lowers due to delayed chamber stroke when braking. Therefore, the brake pulls. Let me explain the gap adjustment of the vehicle installed with the manual slack adjuster. First of all, adhere the slack adjuster closely by the worm screw until the brake shoe does not move any longer. Then, press the brake pedal fully. Unscrew the worm screw by adjusting the stroke of the brake chamber push rod to be front 25 millimeters and rear 30 millimeters. The following are advantages of the automatic slack adjuster. First of all, the lining gap is maintained properly automatically And stable braking performance is assured by keeping the proper chamber stroke all the time. Since there's no need to adjust the lining gap until complete wear, maintenance time is reduced. The installation and lining adjustment of the auto slack adjuster are as follows. The procedure is as follows. Keep the air pressure in the tank at 6 kilograms per square centimeter. Release the parking brake. Apply grease. Install the auto slack adjuster. Rotate the auto slack adjuster clockwise and align the slack adjuster and push rod of the brake chamber. Install the pin. Install the washer and key. Push the control arm of the auto slack adjuster to arrow direction until it touches the internal stopper of the auto slack adjuster. Fix the control unit to the bracket. Rotate the adjusting screw on touch lining with drum. Rotate the adjusting screw 3/4 reverse direction. Press the brake pedal for 20 times to keep the appropriate clearance. Now I'd like to explain troubleshooting of the air brake system. Since every function of the parts is very sensitive, requiring air tightness, they should be kept in maintaining the vehicle. Contents to be kept are as follows. Remove any possibility of impurities inflow into the valves. Check the air dryer, pipe, connector and air tank inside periodically. Apply the specified torque when plumbing the air pipes. Eliminate impurities when reassembling. Tags should be attached. There are 3 types of warning lamps in relation to braking. These are parking brake operation lamp, which turns on when the parking brake is applied, and the brake warning lamp, which turns on when trouble occurs in the brake system. And the warning lamp may turn on by the air master stroke detector due to excessive lining gap when the oil quantity in the reservoir tank drops due to oil leakage of the brake system in the case of the AOH type. Next, the air pressure warning lamp turns on when the pressure of the air tank for the brake system drops down to or below 4.8 to 5.2 kilograms per square centimeter, because braking performance may be lowered by the air pressure drops. System check of the air dryer. The air dryer cartridge should be replaced at an interval of 12 months or 50,000 kilometers driving under normal conditions. If an air dryer fails, the following may occur. When the air tank discharges water or moisture, check to see if the cartridge is polluted, or the cartridge replacement period is exceeded, or desiccation is deteriorated due to the temperature rise of the air tank. In this case, check to see if any heat radiating object is present near the tank. remaining condensed water may discharge for about 3 weeks, even when the cartridge is replaced. So check the system again after 3 weeks. If the air dryer body is hot while the vehicle is stopped under the temperature of 13 degrees, the heater is assumed to be in operation due to wrong power connection. If the dryer is freezing, the heater is open circuit, or the heater operation is poor. In this case, the air dryer assembly should be replaced. Air pressure is purged at the cutout pressure and maintained under the pressure. In this case, check the leakage of the system line. When compressed air leaks out to the governor setting is misadjusted. Air pressure drops to 0 bar gradually after the vehicle stops. In this case, check the system for leakage. If the air pressure dropping time is less than 13 hours, it's assumed to be normal. When the air tank contains engine oil may have flowed in due to compressor failure. A poor air cleaner may cause compressor failure by allowing the inflow of foreign material into the compressor. Now, let's review the troubles due to wrong installation of the auto slack adjuster. The auto slack adjuster should be installed by being pushed to the arrow direction as described above. If this is not done, lining burn, early wear, drum overheating, or tire damage by the heat in serious cases may be caused. In addition, the control arm may be damaged due to abnormal operation. Leaking points of the system are as follows. Though the R12 relay valve is less likely to have air leakage due to the part failure, its frequent replacement should be assumed as valve leakage. If the R12 relay valve is suspected, leak at the seal or connecting points due to inflow of impurities. In the case of the dual brake valve, the internal return spring may corrode due to poor desiccation of the air dryer, and accordingly, poor operation of the dual brake valve may be caused. Besides, impurities due to the rust may be transferred to each part through the air line to cause seal damage around the connecting points, at which air may leak. In the case of the spring chamber, soil or dust can flow into the chamber through the operating points of the chamber push rod, and they may damage the diaphragm, at which time air may leak. Finally, let me explain the causes for early lining wear. There are several causes for early lining wear and brake performance reduction after lining adjustments, such as air leaks, oil leaks, poor gap adjustment, or wrong installation of the auto slack adjuster. We have learned about the brake system of the medium-sized or large buses and trucks so far. The brake system is one of the most important safety devices. Your thorough understanding of the brake system is necessary for perfect maintenance. Hyundai Motor Company has been doing its best to promote effective maintenance. We will continue to do our best to support your maintenance activities. Thank you.